Very good afternoon, students. Am I audible?
Yes, sir.
Yes, sir.
Really sorry, some delay is there in joining meeting. Someone say hello.
Hello, sir.
See, student, this is our result, 24th, January 24th. Only 5 students reached cutoff. Highest is Sri Shailesh. I am appreciating everyone who reached cutoff. So coming days, this top 5 students aim 650. Work more hard. Don't stop. Clear up.
Yes, sir.
Some category students are there. Kritika Jyoti, Neha, Yashika, Tejasri, Yashika, S. Varshini, Naveen Kumar. These targets are very low. If you study biology, chemistry perfectly, you will cross 500. Okay, these 6 students, next Monday, compulsory, you have to reach 500 students. Everyone say hello. Naveen Kumar, respond. Naveen Kumar, Tejasri, Yashika, Neha, Kritika Jyoti, everyone. Remaining students, target at least 580. Okay. Once we'll see the schedule. Yesterday I gave some homework, but no one have done except Harshit. This is our work. Around 53 students are there. Out of 53 students, only 1 student submitted. Remaining students, no seriousness. Okay, students, so without any delay, we'll continue the discussion of the waves. So yesterday, what we have done, briefly I will revise. This is one rope, this is the wall, this is one particle P, this is our origin. What is this? X-axis. What is this? Y-axis. One wave is going right side, and this at the t seconds, this particle P is at a displacement y meter and horizontal distance of this particle P x. Tell me what is the wave equation, everyone? Loudly. Y is equal to how much? A into sine of k into plus x or minus x? Plus x. Next. Very good. Minus omega t plus pi. In the name, it is titled as wave equation, but actually what is this? This is the position of the, the two vertical position of the medium particle, na? Say sir, no? Vertical position of the medium particle after how many seconds? After t seconds. Now I want velocity of that medium particle. What I have to do? Very good. Differentiate on both sides. So I'll write that point. Velocity of medium particle after how many seconds? After t seconds. What is the formula? Velocity equal to? Wrong. Dou y by dou t. Why dou y by dou t? Partial differentiation. Here x is variable, time also variable. When two variables are there, you should not use differentiation. You have to use partial differentiation. What is the meaning of the partial differentiation? Here as time variable, you have to keep x constant. Say yes or no? Response, you have to keep x constant. Only we are analyzing the particle which is at separation x meter only, no? Please say yes or no. So keep x constant. Say yes or no. Substitute this y value nicely here. What we can write? V is equal to dou by dou t of a into sine kx minus omega t plus pi. And a I will write outside. What is differentiation of sine? Very good. Cosine kx minus omega t plus pi. Again, we have to differentiate the term inside the bracket. Na kx minus omega t plus pi you have to write, no? Yes or no? So v is equal to how much here? A into cosine kx minus omega t plus pi. What is the differentiation of kx? K you should treat constant. X also you should treat constant, na? What differentiation of constant, ma? Zero. Minus omega into dou t by dou t. What differentiation of this epoch, initial epoch? Respond. Zero only. Dou t cancels out. So what is the velocity of the particle Vp? Is equal to how much? Minus a omega into cosine kx minus omega t plus pi. I will keep aside. This is equation number 2. What is this representing? Velocity of particle. Velocity of particle, students. not velocity of wave, velocity of particle after how many seconds? After t seconds. What is acceleration of the particle after t seconds? Acceleration of particle after t seconds, how much? After t seconds, how much that equal to?
minus a
Huh?
minus a omega square sin kx minus omega.
Very good, very good, very good. Harshit is telling directly and substitute this value here. Dou by dou t of velocity of the particle, how much? Minus a into omega into cosine kx minus omega t plus pi. So the acceleration of the particle equal to how much here? Minus a into omega. And what differentiation of cosine?
Sin.
Minus sine kx minus omega t plus pi. Once again, if you differentiate this term, again minus omega will come, no? So this one into this one into this one, how much? Minus a omega square into sine kx minus omega t plus pi. This is the acceleration of the particle after how many seconds? This is the acceleration of particle after how many seconds? After t seconds. Is it clear, everyone? Say yes or no. Here, students, if you want to analyze only this particle, time will change. X will be constant, no? Are understanding? Here two cases are there. Case number one, what I analyzed? Case number one, only one particle I have taken, no? One particle I analyzed at a different time intervals. Say yes or no. Vice versa also true, no? What is the meaning of the vice versa? Respond, what is the meaning of the vice versa? At same time interval, different particles also I can watch at a time, no? That is called snapshot. Snapshot means you will take one screenshot, photo you will take, and you will capture the image of the orientation of that all raw particles at a time, no? What is the meaning of photo? Photograph means what, ma? At one particular time, which is capturing your face information. That's all, na? Not understood, huh? Understood or not understood? Huh? Okay, if you not understood, try to understand. Okay, that is the meaning of the snapshot or screenshot or photo shot. What is the meaning of the photo shot? At a time, at one particular time, the position of different particles capturing their positions on single page is called a snapshot. Are you understanding? So case number 2, I am going to talk what? Case number 2, snapshot I am going to talk. What is the meaning of the snapshot, my dear students? At a time, at a specific time, we are observing different particles position. We are observing various particles position. Is my point clear, everyone? If you see the snapshot of one wave, this is a rope, this is a rigid wall. I gave one jerk, then how the rope will be looking like? Like this only, no? Please say yes or no.
Yes, sir.
think red color is not visible, no? So I will use yellow color only. This is a different particles position at a same time, no? Let's say this is a particle P is at this position. One more particle Q is at this position. One more particle T is this position. One more particle R this position. Another particle S is at this position. Various particles we are analyzing. 5 particles position we are analyzing at one specific time. I mean now here which is variable right now? Very good. X is variable. X is variable. X is variable and which is constant? Very good. Time is constant. Okay. But in case number 1, what is the case number 1, my dear students? Case number 1 is what? X is constant. Single particle only we are talking. But time is different timings we are analyzing. Okay. Now, tell me what is the wave equation? Same, this is the origin. What is this? X-axis. What is this? Y-axis. Okay. This is after t seconds some situation. I'm taking one particle at a distance what? X meter. It is at a vertical position how much? Y meter. Tell me directly what is the Y value? Wave equation for particle P. Wave equation how much? Y is equal to same na A into sine of kx minus omega t plus pi. Now I will differentiate with respect to x. I want to study behavior of various particles. With respect to which one I have to differentiate right now? X only, no? Correct or not? So I will differentiate. Shall I call with your permission? That is dou y by dou x. Yes or no? Are you understanding? What a meaning? For different horizontal position particle will have different vertical position. That's the meaning. Correct or not? If x is changing, y also changing. That's all meaning. Okay. So I will differentiate. A can be written outside now. A I will write outside what? Differentiation of sine, cosine, kx minus omega t plus pi. And you have to differentiate this one kx minus omega t plus pi. So that equal to dou y by dou x equal to how much here? A into cosine kx minus omega t plus pi. What differentiation of kx? K will be written outside. Dou x by dou x how much? 1. What differentiation of omega into t? 0. Say confidently. For human beings, confidence is required. Your mind set some answer means, oh, that is my mind only. It is saying some answer means, yes, it is correct only. Why? Because it was heard by my ears. That was analyzed my brain only. So my ear will hear right things. My brain will preserve right things. So it will be giving correct answer only. Correct or not? You should not hesitate. The most awkward thing, if you hesitate yourself. Correct or not? Lack of trust on you. Understood? So correct only, na? I only told na you people. Time only constant I said or not. So what is the differentiation of omega into t? 0. What differentiation of pi? 0. So what is dou y by dou x value? Ak into cosine kx minus omega t plus pi. I will keep aside. Let's say I will keep aside equation number 3. We got here 2 equations. What is equation number 2, ma? This is equation number 2, no? I will write what is equation number 2. From equation number 2, velocity of the medium particle, how much? Minus a omega into cosine kx minus omega t plus pi. What is equation number 3? Dou y by dou x is equal to plus a into k and into cosine kx minus omega t plus pi. What I am going to do right now, I am dividing these two equations. What will happen? A nicely cancel, cosine nicely cancel. What we can write? Vp equal to minus dou y by dou x and into how much? 1 by, sorry, yes, omega by k. Omega divided by k here. So what is the velocity of particle? Equal to what is the ratio of this angular velocity and this wave number? How much? Velocity of wave only, no? Say yes or no? This is the most important relation, students. Direct questions will come. Very important application. Okay. Very wonderful use is there. So everyone should remember this relation between. This is called relation between what and what? Velocity of particle and velocity of wave. Velocity of particle and velocity of wave. So definitely you people will ask me, sir, what is the use of this, sir? Definitely you will be asking, no? Correct or not? Lot of use is there. What is the lot of use? I will explain. I am taking one rope. What is this? One rope I am taking. I am continuously jerking. What is the meaning of jerking? I am producing the waves at a particular moment. This is any snapshot of the wave. What is this? Snapshot of the wave. And this wave is going right side, no? Velocity of the wave is going right side only, no? Yes or no? Understanding or not understanding? Now I am taking one particle P on this. You people have to say this particle P is going upside or downside, you have to say. My question is, this is a concept what we discussed. It is one feeder problem. To digest this concept, I gave one practice problem. I will give that problem. If velocity of wave, direct questions will come, students, based on this. If velocity of the wave is right side, velocity of the wave is going right side, tell the direction of medium particle P. Tell the direction of what here? Medium particle P. Yes or no? How much? It's going upside or downside, I want. Downside. Are you sure? Huh? What is your strategy? How did you solve that? Tell me. I want to know. Please don't guess. In our life, we have to avoid guessing. Understood, ma? Okay? In the share market, by guessing, if you invest money, understood, you will lose all money. Understood? In our life, anything we should do with the scientific reason only. Correct or not, ma? Correct or not? While crossing road also, we have to see left side, right side. Correct or not? Or else what will happen? Accidents will happen. So please avoid that guessing. Tell me, what is that? What is the equation, ma? Very good. Velocity of particle equal to minus dou y by dou x into velocity of wave, na? Yes. Very good. Next. Both are opposite, huh? Oh. So, shall I write velocity of wave equal to how much shall I write? Some plus 2 meters per second. Nothing will happen, na? This kind of strategy very simple. I will use real numbers. At point P, I will draw any tangential line. This is a x-axis and this is a y-axis. So the slope at that point P, how much? Dou y by dou x. Negative or positive? Huh? Very good, negative. I will take minus 1 something. Understood? Huh? Negative only, na? If the straight line coming like this means that is negative slope. If the straight line coming means that is a positive slope. Put all the values here. What we can write? Velocity of particle equal to minus 1 and plus 2. So plus 2 means velocity of the particle we got positive means upside or downside? Upside. So the particle is going which direction? Upside it is going. So what is our answer? P is going upside. You said what? Downside. Very, very important strategical question. Many times in your NEET exam, IIT exam, thousands of time asked. Understood? By that time, if you show your astrological skills, understood? Okay. Simple score, you will lose. 5 marks is not a joke, ma. Most painful. 5 marks is for you 5 marks only, but that 5 marks changed millions of students' life. Understood? I am also one of the student. Understood? Okay. That pain, if you lose the merit quota seat with 20 marks, 30 marks also is appreciated. But with 1 mark, with 2 marks, 3 marks, 4 marks, if you lost means, that is in your throughout your life, you will never forget. Mark my words and this one. Understood? Okay. That 1 mark cost you 1 year. I think I introduced now during that that success meet also one student came na, came or not? Understood? One day he kept on status. Why I attempt that question? He took the screenshot of that question also. On that day, if he would not touch that question, last year only he would have become doctor. By this time, his first year also completed. Are you understanding now? Correct or not? Shall I give one more problem? Will you do it? Will you do it? What?
Yes,
What?
sir.
Will you do it or not? This is one rope here. This time wave is going left side. How it is going? Wave is going left side. And what is that? Find direction of particle P. Find the direction of particle P. Your time starts now.
Upside, sir.
Huh?
Upside.
Upside, Harshit? Confident?
Yes, sir.
Lock कर देंगे.
Yes, sir.
Sir, upside.
Upside. Any more supporters are there, my dear students? Any supporters are there, I am asking you.
Sir, going downside, sir.
Going downside, Tamim is saying going downside. Okay. Let us check what a velocity of particle formula. Minus of velocity of wave into dou y by dou x only, na? At point P, what you have to do immediately? Draw any tangential line. So its slope is how much, ma? Negative or positive? Take any number, no issue. Dou y by dou x is how much? Minus 10 I will take. But a velocity of wave I will take. Left side it is going, na? Minus 2 I will take. Put all the values here. So what we can write? Velocity of particle equal to minus 20 into minus 10. So that is how much? Minus 20. Negative sign means what, ma? Downward. What is the answer? Tamim is correct. Particle is going downside. One more technique also there. Shall I tell the technique? But this only I will believe. I recommend this method only. Understood? See, this is the snapshot. This is a particle P, no? Says or no? After it is going left side means you just draw the movement of this. It is like this only, no? Says or no? Where the particle P has gone? Not understood, no? Earlier this trough is like this, no ma? Trough is like this, na? Where it will go? Left side it is going, na? Says or no? It is going left side means after some very little time the wave will be like this only, no? Please say yes or no. Correct or wrong? Understood or not understood? Where this particle is there, ma? This particle P, when it is going left side, its particle P going this side only, na? Have you seen? This is a position, no? Correct or not? This particle P is slightly gone left side only, no? Observed, this particle P, medium particle P, after traveling for delta t seconds, it went downside, upside. Logically downside only, na? If it is going right side means, if it is going right side means what will happen? That particle P will go upside only, no? Slightly. That's what leave this method. Correct or not? So this is only the perfect method. Clear or not? Okay, okay, why? Because you have to maintain good artistic skills. Why? Because some slightly it goes variation means you cannot identify. That's what it is, very easiest way. Very simple method also. Is my point clear? Now very immediately, let me introduce another concept. Velocity of transverse waves in string. For example, student, this is one horizontal support. This is one light string. What string? Light string. And I attached one block of mass m kilogram. Please tell me what the tension in the string. How much?
mg.
Very good. M into G. Everywhere tension is same. From top to bottom, any point tension is remaining same only. Why? Because this is a light string or massless string. I will assume m prime equal to mass of the string. I only told massless string means m prime is very, very less than m. So mass of the string, and L equal to what here? Length of the string. The ratio of these two things are called linear mass density. What is that, ma? Linear mass density. That is denoted with the symbol mu here. For suppose you continuously plucking at point P. With your nail, you are plucking at point P. Plucking means what? Continuously, you are producing one wave. One time you plucked means you produced one wave. Where it will go? Where it will go, ma? Upside only it will go, no? The path is built in the vertical only, so it will go to top side. Say yes or no? If you pluck two times means two waves you have produced. But here one wave is sufficient. My question is very simple and straight. Find the time taken by the wave. Find the time taken by the wave to reach top side. Find the time taken by the wave to reach topmost position. You know, students, velocity of the, you know, what kind of waves are produced in the string? Transverse waves only, na? Why? The wave is going along y-axis, but the medium particles will vibrate along x-axis only, na? Where particle motion is perpendicular to wave motion, what the type of wave is called? Transverse wave. So the velocity of the transverse wave equal to under root of t by mu. Please remember this formula. No derivation is there and not required also. These are only dimensional based deduced equations only. No derivations are required. Experimentally and by using experimental analysis and dimensional analysis only, we got this kind of equations. You just blindly remember, that's all. Understood? So now tell me what the time taken to reach the topmost position? What time taken formula? Here tension in the string constant, mu also constant, na? I mean the wave is always having constant velocity. Say yes or no? From bottommost point to topmost point is going with the constant velocity. What a time taken by the wave to travel from P position to Q position? Distance by velocity only, no? Say yes or no? Distance by velocity. What a distance equal to here? Length L by velocity how much? Under root of T by mu. This is the time taken to reach the point Q here. Are understanding? This is only light string. Shall we see string with mass also? Shall we see or not? Okay, we will see that also. Now this time I am taking string with mass. String with mass. It is having uniform density. Which density? The string is having uniform linear density. This is a horizontal support. What you attached? This time one string with mass I attached. What I have done? A string with the mass I attached. Let's say the length of the string equal to how much? L meter. At point P, I gave one time jerk. How many times? One time jerk I have given. So how many waves I will produce? One wave I have produced. Okay. Let's say m equal to mass of the string. Let's say m equal to what? Mass of the string. You people find time taken. Find time taken by the wave to travel from where to where? From where to where, students? From P position to Q position. Yes or no? Do you say directly shall I use this formula time taken equal to distance by velocity formula? Shall I use a? No. Why? Velocity is not constant. Na? Velocity of transverse wave how much? Under root of T by mu, no? But at different points tensions are different. No? At bottommost point tension is 0. As you are going upside, tension will increase. So direct method you should not use. Are you understanding? Here which method you have to use here, my dear students? Which method? Respond. Something is variable means which method you have to use? Very good. Integration method. Very powerful method. Who is strong in this integration method? Final NEET exam, 15 questions to 25 questions easily you can grab. Easily you can steal the marks. Understood? Who is strong in this integration method? For them, additional asset. Are you understanding? Out, check any question paper of your NEET or medical exam. If 50 questions are there, minimum 10 to 15 questions related to integration. Check it. If you have any doubt, take out all previous year question papers and check out. Solutions alone you check out. That is the power of the integration method. Understood? Here we got one opportunity. So what I have to do then? Fix one frame of reference. I will take this origin. This is x-axis. This is which axis? Y-axis. I am taking one small element. What I am taking? One small element is there at a distance y. There is one element dy. What is the velocity of the wave when it is passing through that element or point? What a formula? Under root of T by mu only, no? Yes or no? Velocity of the wave I can write change in vertical position of the wave by change in time taken I can write, no? What is the tension at that point P here, students? I will draw the free body diagram of this element. What is the length of the element? Y meter, no? Yes or no? If you see the free body diagram of that element, how many forces are acting? Earth is pulling downside, means M prime into G, tension upside, no? Yes or no? What tension equal to? M prime into G. What the mass of this element, shaded one? Linear mass density into Y only, no? Please say yes or no? What a linear mass density equal to? total mass of the wire by total length of the wire into G. Are you understanding? This small element is pulling this lower element upside with tension T. Lower element also pulling the element downside with the same tension T. Na?
So
Correct or
what
not?
is Y in that, sir?
What is that?
Y.
Y is the length of this lower element.
Okay, sir.
This is a small element what we have taken. Just below another element is there, na? Y.
Yes, sir.
This length is dy. The small element is pulling the big element upside with tension T. For every action, there is an equal and opposite reaction. Na? So small element also pulling the element downside with the same tension T. Understood or not understood?
Understood, sir.
Tension value how much? M by L into Y into G by mu. M by L is nothing but mu only, no, my dear students. Please say yes or no. Please say yes or no.
Sir.
Mu cancels out. Correct? Say yes or no.
Yes, sir.
Dy equal to how much? Y power 1 by 2 into G power 1 by 2 into dt. So y power 1 by 2 send this side. So y power minus 1 by 2 into dv is equal to how much? G power 1 by 2 into dt. Integration. You have to do on either side. So put the limits from where to where? 0 to t, and y value from where to where? 0 to y here. What integration of y power minus 1 by 2? Y power minus 1 by 2 plus 1
Plus
divided
1
by
by minus 1 by 2.
minus 1 by 2 plus 1. Put the limits from where to where? 0 to y, and g power 1 by 2 into integration of 1 into dt how much? T from
T.
0 to t. So put the limits, what do you get? Y power 1 by 2 divided by 1 by 2, put the limits from where to where? 0 to y, and root of g, and put the upper limit, what do you get? T minus 0, and 2 and under root of y from where to where? 0 to y, and root g into t. Put the upper limit first. So what do you get? Root 2y minus 2 under root of, sorry, one mistake I have done. Such elements are lying from where to where, ma? 0 to L only, no? Wave is traveling from 0 to L only, na? Then you have to change the limits. So this is root L, na? That will be root g into t. So what a time taken to reach the upside? 2 under root of L by g is your answer. I hope everyone understood very well. Understood? Huh?
Yes, sir.
Finish down. So next one, for example, I'm taking any solid medium. What the name of the medium? This is any solid metal, for example, or water. Any bulk medium I am taking. What the meaning of the bulk medium? Anything that have volume. Like it can be a solid substance or liquid substance or gaseous substance. Let's say the bulk modulus equal to B. Let's say its density equal to rho. If I tap this solid metal this side, one wave will go right side only, no? Right or not? So the velocity of the longitudinal wave, if you tap or if you hammer left side, the particles will vibrate right side, I mean along x-axis. Wave also will go along x-axis. Here particle vibrations and wave motion confined in x-axis only, no? What is the name of that wave? Very good, longitudinal wave. So I can write velocity of longitudinal wave. Velocity of longitudinal wave V is equal to under root of bulk modulus of that medium divided by density of the medium. When you have to apply this formula you have to apply only for
Longitudinal.
bulky substances. Bulky means what? Which are having volume substances only. It can be a gas, it can be a liquid, or it can be a solid also. Understood? Substances. Sorry, it is valid for only solids and liquids only. Why? Because gas is different phenomena. Atomicity also matters. So it is valid for only solids and liquids only. Understood? And which are having volume only. Similarly, velocity of longitudinal wave for only linear substances. Linear substances means what? Volume is not there. Like a linear wire, right? Linear wire, linear rod, linear pipe which is flowing some water or something. That is also very narrow passage. Na? In such scenario, velocity equal to how much here? Under root of Young's modulus by density. So it is most of the cases valid for solids only, not liquids. Because Young's modulus is coming for only wires and metals only, na? That too linear medium, like it's valid for only strings only. Valid only for strings and wires. Above formula, it is valid for rods, bulky substances like rods, liquids, etc. Understood? Same way, if the longitudinal wave is going in the gas, that is called Newton equation. That is proposed by Newton. So the velocity of sound, velocity of longitudinal wave, best example for longitudinal wave is what? Sound wave only. So the velocity of longitudinal wave equal to how much here? Under root of pressure of the gas by density of the gas, students. Understood? So what Newton has done, he has taken one gas chamber. What he noticed, when wave is propagating through this gas chamber, he treated that process like a isothermal process. Which process? Isothermal process. That's what he got this equation. But later his assistant Laplace observed that when wave is propagating through any gas, slightly temperature will change. So it is not isothermal process, but it is a adiabatic process. Externally, we are not heating the gas, na? So that is called Laplacian correction. According to Laplacian correction, in science, what will happen? Someone deduced equation, someone will correct. Understood? So for Newton's velocity of the longitudinal wave, he said it is a adiabatic equation. So just you have to add gamma p. What is gamma value here? Ratio of molar specific heats of the gas. Understood? In the numerical, you have to be very crystal clear. If the process is isothermal, means which equation you have to select? First one, under root of P by rho. no, nothing is mentioned, means reality, means adiabatic only na. So below equation you have to select. Specifically, if we mention isothermal means you should not touch this equation, students. Okay. Okay, students. So that's all. Now we will meet in the next session.
Sir,
Thank you, students.
I have a doubt, sir.
Please tell
Sir, in that sum you gave, no, sir,
which sum.
whether the particle is moving downwards or upwards. In that second sum, how dy by dx is negative, sir?
Slope is negative only, na, Harshit?
How, sir? Can you explain that?
This slope is decrement only, na? It's representing decrement only, no?
Yes, sir.
Decrement means negative only. This is positive slope.
Okay, sir.
Understood?
Okay, sir. Yes, sir. Yes, sir.
This is negative slope. Remember, everyone,
Okay.
the line is coming like this means that is negative slope. With x-axis, it is making more than 90 degree. And positive slope means with x-axis less than 90 degree it will make. This is a positive slope. This is which slope? Negative slope. These are small basics only important for your life, students. Understood?
Yes, sir.
We are keeping masks, but after eating, we won't wash our hand properly. Are you understanding? Before eating, we won't wash hand, but we'll wear masks. Are you understanding? We'll touch this, we'll touch somewhere, but we won't wash the hands now. Right or not? Yes or no? So small mistakes only, and we are using sanitizers. We are wearing masks, but small basics only. We have to be very cautious. Okay. Thank you, students. We'll meet in the next session. Bye. Thank you.
Thank you, sir.